In this video, we will discuss spur gears in a clear and structured way. We will start with the basic concept of a spur gear, and then continue with the key parameters and calculations used in gear design. The main goal of this video is not only to draw a spur gear in SolidWorks, but also to understand the calculations behind it, so the resulting design is technically correct and suitable for real mechanical applications. By understanding these fundamentals, we are not simply relying on automatic features, but truly knowing the reasoning behind every dimension and shape of the gear we create.
The main input parameters in spur gear design used for drawing are the number of teeth, the module, and the pressure angle. The number of teeth determines the gear ratio, the module defines the size and spacing of the gear teeth, and is calculated as the pitch diameter divided by the number of teeth, while the pressure angle is the angle between the line of action and the tangent to the pitch circle, with common standard values of 20 degrees. The main input parameters, including the number of teeth, the module, and the pressure angle, form the basis for determining the geometric parameters of a spur gear, namely the addendum, dedendum, pitch diameter, and base diameter. Addendum is the radial distance from the pitch circle to the tip of the gear tooth, which defines the tooth height above the pitch circle, and its value is generally equal to the module. Dedendum is the radial distance from the pitch circle to the root of the gear tooth, providing clearance between meshing teeth, and its value is typically 1.25 times the module. Pitch diameter is the diameter of the pitch circle, which represents the primary working circle where effective contact between two meshing gears occurs, and it is calculated as the product of the module and the number of teeth. Base diameter is the diameter of the base circle used to generate the involute tooth profile. It is always smaller than the pitch diameter, and is calculated as pitch diameter multiplied by the cosine of the pressure angle.
Open SolidWorks and create a new project. Then, create the variables using equations. If the equations menu is not visible, go to Tools and select Equations. Alternatively, if you want the equations panel to be displayed permanently, go to Tools then Options. Then Feature Manager and enable Show Equations. Once the equations window is open, enter the variables and equations based on the previous discussion. In this example, the main input parameters are module equals 2 and number of teeth equals 40. These global variables will serve as the foundation for designing the spur gear in SolidWorks. Select the front plane as the sketch plane. Use the circle tool to draw a circle. Then assign the diameter value using the equation PD plus 2 times A, where the factor 2 accounts for the addendum applied on both sides of the diameter. After completing the sketch, create the 3D model by extruding it with a thickness of 8 mm. Next, create 3 concentric circle sketches that will be used as references for generating the spur gear teeth. The middle circle is assigned the pitch diameter, PD. The distance between the top circle and the pitch circle is set to the addendum, A. while the distance between the pitch circle and the bottom circle is set to the dedendum, B. These three circles serve as the main references for constructing the spur gear tooth profile. Create a vertical construction line as the initial reference. Then, draw an arc using the 3-point arc tool to form the basic tooth profile. Next, create a construction line from the center of the circle to the lower point of the arc. Set the arc to be tangent to this construction line. To define the pressure angle, draw an additional construction line in the direction of the pressure angle. Make sure the arc and the construction line are tangent. Ensure that the tangency point lies exactly on the pitch diameter, PD. Then assign the angle value to PA, for example, 20 degrees. Copy this construction symmetrically to the opposite side. Next, create construction lines to define the tooth angle. Draw the construction lines as shown. Make sure this construction line is perpendicular, 90 degrees. And positioned exactly at the center between the right side tooth boundaries. Assign an angular dimension between this construction line and the vertical construction line with a value of 180 degrees, z, where z is the number of teeth. Ensure that the sigma symbol, sigma, appears, as its absence may cause calculation errors in the following steps of the video. Once all references are created, trim the unnecessary lines. Perform an extruded cut to create a single tooth. Finally, use the circular pattern feed. structure and set the number of instances to Z to generate all teeth around the gear. At this stage, the spur gear modeling process is complete. In the next video, we will continue with the creation of the center bore and the assembly process. In this design, 8 holes are created in the gear to reduce filament usage during the 3D printing process. The hole design and placement do not need to be exactly the same as shown in the video. However, if you wish to follow the same design, the detailed steps and dimensions can be found in the video. After completing the holes on the 40-tooth gear, the next step is to create a 70-tooth gear. This is done by opening the equations menu and changing the value of Z from 40 to 70. During this process, an error occurs in the video because, in the previous step of defining the tooth angle, the equation did not generate the sigma symbol. Once this error is corrected, the gear modeling process can continue without issues. The next step is to create a nut, which will be used to simplify the assembly demonstration of the two gears. The dimensions and modeling steps for the nut are also explained in detail in the video. Create a new project for the assembly process. Insert the 3-part files that were created earlier: the 40-tooth gear, the 70-tooth gear, and the nut. Set the nut as the assembly reference by fixing it in place so that it cannot move. For a clearer and more detailed explanation, please refer to the video. To simplify the assembly process, especially when creating gear motion animations, reopen the 40-tooth gear and 70-tooth gear part files individually. Add construction lines on the pitch diameter, PD, of each gear. These construction lines serve as additional references to make mating the two gears easier, more accurate, and more stable. After adding the construction lines, save both gear files and return to the assembly to continue the mating process and motion simulation.